Welcome. Today, we are going to learn how to identify linear functions from tables or points. So again, now this is very important, in order for it to be a linear function, the rate of change or slope must be constant. Now, the rate of change or slope is not just the change in y like a lot of students want to do. The rate of change or slope is the change in y over the change in x. So you always got to take into account how x is changing as well. So what I do when I'm given a table is I find the change going from this 1 to this 7, and I write it here. So to go from 1 to 7, it's an increase of 6. To going from this point here to 3, 7 to 3, I have an increase of, actually it's a decrease of, did I write that down right? I think that was supposed to be a 13. Yeah, it's an increase, again, of 6. Yeah, that was supposed to be a 13. So it's an increase of 6. But I can't just look at that and say, hey, those two are constant. I got to make sure that the change in the x is constant as well. So in other words, to go from 17 to 18, that's an increase in 1. To go from 18 to 19, that's an increase in 1. And now, rate of change or slope is the change in x versus the change in y over or versus the change in x. So you take that change in y, divide by the change in x, which is 6 over 1, and you do the same thing for the next one. And as long as it works between every point, that's the thing, you need to go between every point. So if there was another point in this table, I would have to do the next one to make sure, because it might start bending later on. But this one is definitely linear. If they give me a set of points, then what I have to do is I actually go, okay, what's the change going from this y to that y? Well, to go from 18 to 16, it's down 2. And I'm going to put that over the change going from this x to that x. Make sure you go to the x, 6 to 7. Well, that's a change in 1. So that's a negative 2 over 1 going from this point to this point. Now let's do the next point. I'm going to go from 16 to 6. Well, that's a change down 10. So now, if the change in x is 5, it will be linear. But I'm going from 7 to 8. That's a change in 1. Those are not equal. That's non-linear because the rate of change is different. Okay, let's do another one. And now, by the way, these two, if you notice, the x went up by 1 both times. X went up by 1. That doesn't have to happen. They don't have to give you 3 points that are consecutive. They can give you points that are further away. So in other words, again, you have to take the time to find the difference between the y's and the x's. 17 to 5 is going to be down 12. Going from negative 5 to negative 1 is going down, up, positive direction, 4. So the rate of change between this first point and the second point is going to be a negative 12 over 4, which reduces to negative 3. Now let's do this next point. To going from 5 to negative 7, again, that's going to be down 12. And going from negative 1 to 3, that's going to go up 4. Again, we get negative 12 over 4, which reduces to negative 3. That is linear. Now let's do a set of ordered pairs. Again, if you'll notice, the x's are not consecutive. So I'm going to first go, okay, to go from this first y value to the second y value, or my change in y is going to be up 4. Going from negative 6 to negative 2 is up 4. To go from 9 to negative 3, that is going, again, up 6. That reduces to 2/3. So the rate of change or slope from this point to this point is 2/3. But now let's see how it is going from the second point to the third point. To go from this y to this y, I went it looks like up 2. And then to go from this x to this x is up 6. Well, that reduces to 1/3. That is not the same. That is non-linear because the rate of change was different between the 3 points. So again, you got to always check every point. Now, you are going to be given some harder ones. Have a calculator ready. You might be given some fractions, right? There's nothing wrong with fractions. I actually recommend you don't do it with a fraction, or with a calculator, I mean, because it's easier to calculate slope without. Again, what I'm going to do is I'm going to go from this point to this point, or that y value to that y value, and to go from 3 to 6 is an increase in 3 plus an extra half. So I increased by 3.5. The x increased by 2, going from 6 to 8. This increased from 6.5 to 8.5, so it looks like that's going to go up 2, would put me at 8.5. So it actually isn't 2, it's going to be 1 3/4. Because if I add 3/4 to this, that's going to be 7 1/4, and then one more would be 8 1/4, right? Try to think through it. Don't always rely on a calculator. Here, to go from 8 to 10 is an increase in 2. Now, I really don't have to do this over this because I notice the denominator is the same. This change would have to be the same as well. When I say denominator, the change in x's. So the change in y over the change in x is not the same. 3 1/2 over 2 is not the same as 1 3/4 over 2. This one's nonlinear. So we don't even have to take the time to simplify the slopes. But now here, let's look at this one. Again, to go from -8 to +1, that's an increase of 9. Over. To go from -8 1/2 to -4, well, if I add 4, that gets me to a -4.5. So I got to add 4.5. So I'm going to add 4 1/2. So there's my change in y over my change in x. Now let's do the next one. To go from 1 to 10, that's an increase in 9. Over. To go from -4 to 1/2, well, that's going to go -4 to 0 is +4. Oh, and a half. Again, I don't have to take the time to reduce this. I notice that those two fractions are equal. This is linear. So just remember, the rate of change has to be the same between every single pair of points, between the first point and the second point and the third point. If they give you a fourth point, between the third point and the fourth point, and so forth and so forth. If you have questions, bring them to class.